There is a double-hulled canoe tied to a pier in Honolulu. Its name is Hokulea. The hulls are wood and fiberglass, the two masts carry crab claw sails, and there is no engine, no compass, no chart, and no electronic instrument of any kind aboard when it sails the way it was built to sail. The name is a Hawaiian word for a single star. That star is Arcturus, the brightest star in the northern sky after the spring constellations rise, and the Hawaiians called it Hokulea, the star of gladness, for a precise reason. Arcturus passes directly over the Hawaiian Islands. Stand on the deck at the right hour of the right night, look straight up, and the star sits at the top of the sky, almost exactly overhead. A navigator who knows that one fact can find Hawaii from the open ocean. Half a world away, and roughly 4,000 years earlier, a scribe in Mesopotamia pressed a list of stars into wet clay. 2 cultures, the same sky. This is the story of what they each worked out, and where the truth is stranger than the legend. The legend goes like this. You may have heard a version of it. The claim is that Polynesian star knowledge matches the records of ancient Sumer exactly, that the same celestial map appears on both sides of the planet, and that the only explanation is a shared source older than either culture, sometimes named as the Anunnaki, the supposed sky beings of Mesopotamian myth. It is a seductive story. It is also not what the evidence shows. The evidence shows something I find more interesting and harder to explain away. 2 peoples who never met, who spoke unrelated languages, who were separated by the widest ocean on Earth and by thousands of years, built systems for reading the sky that rhyme with each other at the level of deep structure. Not because one taught the other, because the sky is the same sky for everyone who looks up, and the human mind, given that sky and a hard problem to solve, tends to arrive at the same answers. The match is real. The reason for the match is not contact. The reason is the sky itself and the shape of the problem. So this is the question we're going to take seriously for the next hour and a half. When 2 civilizations that could not possibly have spoken to each other produce sky knowledge that lines up what is actually going on. We're going to look at real objects in real museums and real people with real credentials, living and dead, navigators and scholars. We're going to separate what is established from what is inferred carefully, because the difference matters, and we are going to test the exact match legend directly, give it the strongest version of its own case, and then see whether it survives contact with the record. What I think you will find is that the honest answer is bigger than the legend, not smaller. If you find that the careful version of a question is more satisfying than the dramatic version, this channel is built for you, and subscribing tells the algorithm to show this kind of work to other people who want it. That is the only ask. Now back to the sky. Let us start with what mainstream scholarship actually establishes, because the established picture is solid, and it is the floor we build on. First, the 2 traditions had no contact. The peoples who settled the Pacific are Austronesian. Their ancestral language family traces back to Taiwan and the islands of Southeast Asia, and the archaeological signature of their expansion into the open Pacific is a style of pottery called lapita, which spread eastward across the islands of the southwest Pacific roughly 3,000 years ago. The settlement of the Far Eastern Islands came later still. High-precision radiocarbon work, led by the New Zealand researcher Janet Wilmshurst and her colleagues, and published in the early 2010s, dated the human settlement of East Polynesia to a surprisingly narrow and recent window, with the central islands settled around the 11th and 12th centuries of the Common Era, and the most remote islands, Hawaii and New Zealand and Rapa Nui, settled around or after that. Mesopotamian civilization, by contrast, was already writing on clay by approximately 3,200 BCE, and the great astronomical texts we will discuss were compiled more than 1,000 years before the first canoe reached Hawaii. These 2 worlds did not overlap in space, and they barely overlapped in time. There is no trade route, no shared vocabulary, no artifact that travelled between them. On this, the specialists do not disagree. It is worth saying plainly how we know the Polynesian navigation was real, because the case rests on 3 independent lines of evidence that all point the same way. There is the ethnographic line, the methods recorded directly from living master navigators by researchers like David Lewis, before the knowledge faded, methods detailed enough to be taught, learned and used. There is the experimental line, the voyages of Hokulea and the canoes that followed it, which proved by doing that those methods actually work across thousands of kilometres of open sea, And there is the archaeological line, the trail of settlement dates and artifacts, and the genetics of the people, the plants, and the animals, which shows the islands were reached in a deliberate directed sequence rather than a random scatter, and reached with the crops and livestock of intended settlement carried aboard. When three independent kinds of evidence, the testimony of practitioners, a successful repeatable experiment, and the physical archaeological record, all converge on the same answer, that answer is about as secure as anything ever gets in the study of the human past. Second, both traditions were real, sophisticated, and observational. The Polynesian system was a navigational science carried entirely in memory, in chant, and in apprenticeship with no writing at all. The Mesopotamian system was a written science, recorded on clay in the world's first script, and it produced the longest continuous record of scientific observation that survives from the ancient world. These are not the dreamy half-myths that the legend needs them to be. They are bodies of hard, checkable knowledge. And here is the third established point, the one the whole episode turns on. Both systems are built on the same physical foundation, which is the horizon. Both divide the circle of the horizon into named points, and both anchor their entire method to where specific stars rise and set against that circle. That shared foundation is not a coincidence, and it is not a borrowing. It is the natural consequence of standing on a turning planet and watching the sky. Let me show you exactly how each one works, because the rhyme is in the details. Here is the break from the simple version of the story, the place where it gets structural. When most people picture ancient star knowledge, they picture constellations, pictures drawn between stars, a lion here, a scorpion there. Constellations are real, and we will get to them, but constellations are the surface. The deep structure of both the Polynesian and the Mesopotamian systems is not the pictures. It is the horizon, divided into a fixed set of compass points, and the rule that a given star always rises in the same point and sets in the matching point on the opposite side. Think about why that rule exists. The Earth turns on a fixed axis. A star, for the span of a human life, sits at a fixed distance from the celestial pole, so that star traces the same arc across the sky every single night, rising at the same bearing on the horizon and setting at the same bearing, drifting only slowly across the seasons and the centuries. This means the horizon can be used as a dial, and the rising and setting points of stars are the numbers on that dial. Both cultures discovered this. Neither could have avoided discovering it, if they watched long enough and needed the answer badly enough. The Hawaiian version is called the star compass, and the modern reconstruction of it is the work of one man more than any other, the native Hawaiian navigator Nainoa Thompson, who built it in the late 1970s and the early 1980s, as he relearned an art that had nearly died out in the islands. The star compass divides the horizon into 32 points, grouped into 4 quarters. The eastern quarter, where everything rises, is Hikina. The western quarter, where everything sets, is Komohana. North is Akau, south is Hema. Each of the 32 points is a house, with its own name, and the central idea is devastatingly simple and powerful. A star belongs to a house. It rises out of its house in the east, swings across the sky, and sets into the mirror image house in the west, and it does this every night of the navigator's life. Memorize which house a star lives in, and that star becomes a bearing. When it sits low on the horizon, rising or setting, you can steer by it, directly. When it climbs too high to use, another star is rising into the same house behind it, and you switch to that one, and then the next, following what navigators call a star path, all night long, holding a single heading by handing off from star to star as the sky turns. The Hawaiian sky the navigators rebuilt is populated with named stars, and the names tell you the system was lived in, not theorized. Arcturus is Hokulea, the star of gladness. The brilliant Sirius carries the name Ah, the burning one. The Pleiades, that small tight cluster that has caught every human eye that ever looked up. The Hawaiians called Makali, the little eyes, and we will come back to that cluster, because it is the single best example of two civilizations seizing on the same patch of sky, for the same reason without ever meeting. Navigators learned the sky not star by lonely star, but in lines, sequences of stars that rise in roughly the same place one after another through the night, so that as one climbs out of usefulness, the next is already lifting into its house behind it. To hold a course toward a distant island for a week, a navigator might follow a dozen stars in succession down a single bearing, a relay race run against the turning of the Earth. The whole of it lived in memory. There was no page to turn to. The page was the navigator's own trained mind, and the cost of forgetting was the boat. This southern sky gave the navigators a second anchor, the constellation Europeans call the Southern Cross, which the Hawaiians knew as Hanaya Kamalama. It is a small, bright, kite-shaped figure, and when it stands fully upright above the horizon, it points almost exactly at the south celestial pole, the way the North Star marks north for travellers in the northern world. But the Pacific navigators went further than direction. They read the height of the cross. As you sail south, the Southern Cross climbs higher above the horizon, and the angle it reaches at its upright moment changes with your latitude in a steady, learnable way. A navigator who knew, in his trained eye, how high the cross should stand at a familiar island could read his north-south position from it directly, without ever naming a number, simply by knowing how the sky should look from home and watching it tilt as he travelled. The sky was the instrument, and the navigator's memory was the scale engraved on it. Now hold that picture in your mind and travel 4,000 years back and 7,000 kilometres west to Mesopotamia, to a two-tablet text the Babylonians called by its opening words Mul Apin, which means the Plough Star. The oldest surviving copies date to around the 7th century BCE, but the observations they encode are older, reaching back toward the start of the first millennium BCE and earlier. Mul Apin is, among other things, a star catalogue, and the organising principle of that catalogue is not constellations as pictures, it is the horizon and the rising points of stars upon it. The Mesopotamian scribes divided the band of sky where stars rise into 3 roads, 3 paths running across the eastern horizon. The northern path they assigned to the god Enlil. The central path straddling the celestial equator they gave to the god Anu. The southern path belonged to the god Ea. Every important star was filed under one of these 3 paths, according to where on the horizon it rose. Read that sentence again and compare it to the Hawaiian star compass, a horizon divided into named bands. Stars sorted by their rising point on that horizon. The rising point used as the fundamental coordinate. This is the same idea. It was invented twice by people who never met, because it is the idea the sky hands you when you ask it where things are. So what does that convergence actually mean, and how far does it go? This is the part worth slowing down for, because it is where the legend and the truth split cleanly apart, and the truth turns out to be the deeper claim. The legend says the systems match because they descend from one source. But look at what the 2 systems were each built to do, and you find that they diverge precisely where their purposes diverge, and they converge precisely where the sky forces them to. That pattern, convergence where physics dictates, and divergence where culture dictates, is the fingerprint of independent invention. It is the opposite of what shared transmission would leave behind. Let me make that concrete. The Polynesian system was built to answer one overwhelming question. Where am I, on an empty ocean, with no land in sight, and which way is home? Everything in it is optimized for finding position and holding a heading. And so the Polynesian navigators developed something the Mesopotamians never needed and never had, the concept of the zenith star. Here is the idea, and it is one of the most elegant pieces of practical astronomy any culture ever produced. A star, as the Earth turns, traces a circle in the sky. For an observer at a particular latitude, one special star will pass directly overhead, through the exact top of the sky, the zenith. Which star that is depends only on your latitude. The star whose distance from the celestial equator equals your distance from the Earth's equator is the star that crosses your zenith. So the zenith star is a latitude marker written on the sky. For the Hawaiian Islands, sitting near 20 degrees north of the equator, that star is Arcturus Hokulea, the star the Great Canoe is named for. A navigator sailing up from Tahiti toward Hawaii watches Arcturus climb higher and higher toward the top of the sky night after night, and when it passes directly overhead, he knows he has reached the latitude of Hawaii, and he turns and runs down that line of latitude until the islands rise out of the sea. For Tahiti itself, sitting near 18 degrees south, the zenith star is Sirius, the brightest star in the whole night sky, which the Tahitians knew well. 2 islands, 2 overhead stars, 2 latitude markers hung in the heavens. That is the Polynesian system doing the one thing it was built to do, and doing it with nothing but the naked eye and a trained memory. The Mesopotamians never developed the zenith star, and the reason is simple and revealing. They were not crossing an open ocean. They lived on land between 2 rivers, and the question that consumed them was not where am I, but when is it, and what does the sky portend? Their astronomy was a calendar science and an omen science. They wanted to know when to plant, when to hold a festival, when a month should have an extra day inserted to keep the lunar calendar in step with the sun, and whether the gods were signalling famine or war or the death of a king. And so they built the part of sky reading the Polynesians had little use for. They tracked the heliacal risings of stars, the moment each year when a star first becomes visible in the dawn before sunrise after a season of being hidden in the sun's glare. Mul Apin lists these dates star by star, a calendar written across the year in first appearances. The northern, central and southern paths of Enlil, Anu, and Ea were a framework for timing the year and reading the heavens for meaning, not for steering a boat. Same horizon, same rising points. Completely different question asked of them. That is the divergence that culture dictates. And then there is the convergence that physics dictates, and it goes deeper than the horizon framework. Consider the problem of keeping a long-term record. The Mesopotamians, because they had writing, could do something the Polynesians physically could not. Starting around the middle of the 7th century BCE and continuing for nearly 6 centuries, Babylonian astronomers kept what scholars now call the astronomical diaries, a night-by-night log of the positions of the moon and the planets, the weather, the river levels, and the prices of goods in the market. It is one of the longest continuous scientific data sets ever assembled by any civilization, ancient or modern, running from roughly the 7th century BCE down into the 1st century BCE. With that record, they did something extraordinary. They detected the hidden cycles. They worked out that lunar eclipses recur in a pattern of about 18 years, the cycle we now call the Saros. They learned to predict eclipses and planetary positions with arithmetic, using number sequences that climb and fall in steady steps, an early form of mathematical astronomy, with no model of the solar system behind it, just patterns extracted from centuries of patient observation. The Polynesians could not write, so they could not accumulate a 600-year ledger. But they faced their own version of the long memory problem, and they solved it the only way an oral culture can, by encoding the knowledge into chant, into named star paths, into apprenticeship that bound a master navigator to a student for years until the entire sky lived inside the younger man's memory. Different storage media, writing versus memory, but the same underlying recognition that the sky's value is in its long-term regularities, and that those regularities must be captured and preserved across generations. That recognition is not Mesopotamian and it is not Polynesian, it is human. Take the single sharpest example of that shared human reflex, the Pleiades. It is a small, faint, tight little knot of stars, not bright, easy to overlook, and yet almost every sky-watching culture on Earth singled it out and built a calendar around it because of an accident of where it sits. The Pleiades lie close to the path the sun travels through the year, so the cluster vanishes into the sun's glare for a season and re-emerges on a reliable date, which makes it a natural clock for the turning year. In Mesopotamia, the Pleiades were among the most important objects in the entire star catalogue. In Mul Apin they are written with the star sign doubled, the stars of stars, and the changing relationship between the Pleiades and the moon was used as a rule for deciding when to insert an extra month into the calendar to keep it true. Thousands of kilometres away and many centuries later in Hawaii, the appearance of those same Pleiades, Makali'i, rising in the eastern sky in the evening in late autumn, marked the beginning of the Makahiki, the long season of harvest and rest and the turning of the Hawaiian year. Two cultures with no possible contact both looked at the same faint smudge of stars, and both decided it would govern their calendar. The legend would call that a shared secret handed down from a single source. It is something simpler and far stranger. It is two peoples independently noticing that this particular cluster keeps better time than almost anything else in the sky, and trusting it for exactly the same reason. Here is the line I want to draw as sharply as I can, because the rest of the episode depends on it. What is established is that both cultures built horizon-based rising point star systems independently, and that the systems converge on physics and diverge on purpose. That is not in serious dispute among the people who study either tradition. What is inferred, and what I am arguing, is that this convergence is the natural product of a shared sky and a shared mind, not of a shared teacher. The inference is strong, because the divergence on purpose pattern is exactly what independent invention predicts, and exactly what transmission does not. but it is an inference, and I want you to hold it as one. Now let us take the other explanation, the legend, and give it the fair hearing it deserves. The popular claim deserves a serious examination, not a sneer, and I want to give it one, because the people who believe it are not stupid and the appeal of it is real. The claim, in its strongest form, runs like this. The Sumerians, the oldest civilization we can read, left text describing the Anunnaki, a group of powerful sky-associated beings. The same text contained detailed astronomy. Cultures all over the world, including in the Pacific, share strikingly similar star lore and creation stories involving sky people. The simplest explanation, the argument goes, is a single ancient source of knowledge, predating all of them, from which these fragments descend. And in support, advocates point to specific, real objects. They point to a circular clay tablet from the great library of the Assyrian king Ashurbanipal, now held in the British Museum, covered in star names and divided into segments, which the aerospace engineer Alan Bond and the spacecraft systems engineer Mark Hempsel argued, in a book published in 2008, was a record of a specific astronomical event, an asteroid impact, dated by their reconstruction to the 32nd century BCE. They point to the writings of Zecharia Sitchin, who published The 12th Planet in 1976, and argued across a series of books that the Sumerian texts, read in his way, described the Anunnaki as a technological species from a hidden planet. The case has named artifacts, named researchers with engineering credentials, and a specific date. By the standards of this channel, it has the right shape, so why does it not hold? It does not hold for three reasons, and I want to give each one plainly. The first reason is the translation problem, and it is decisive. Zecharia Sitchin was not a Sumerologist. The scholars, who can actually read Sumerian and Akkadian, people who have spent their careers with these texts, are nearly unanimous that his readings do not survive contact with the language. The word Anunnaki, in the texts themselves, refers to a category of gods, the offspring of the sky god Anu, a word built from ordinary Sumerian elements meaning something like the princely offspring or those of royal seed. It is a theological term, not a description of a spacecraft crew, and the planet Sitchin, called Nibiru, appears in the actual astronomical text as a celestial body associated with the god Marduk, most often identified by Assyriologists with Jupiter or with the position the planet Jupiter occupies, not as a hidden world on a long orbit. The detailed engineering story is built on translations the experts say the words will not bear. That is not academia refusing to engage. The engagement happened, in detail, and the readings failed. The second reason concerns that circular tablet and the impact claim. Here I want to be careful and fair. The tablet is real, it is genuinely in the British Museum, and it genuinely came from the library of Ashurbanipal at Nineveh. The Bond and Hempsel reconstruction is a serious piece of work by serious engineers, and it is not a hoax. But it is contested at the foundation. The mainstream reading of that tablet, held by the Assyriologists who specialize in Mesopotamian astronomical texts, is that it is a copy of an astronomical compendium of a well-known type, a list of constellations and their positions organized into segments of the sky, not the eyewitness record of a single dated catastrophe. The impact interpretation requires a chain of assumptions about which star names map to which modern stars and about what the diagram is depicting, and each link in that chain is disputed by the people who read the script for a living. When a reading depends on a long chain of contested assumptions, and the simpler reading, that it is a standard star list, explains the object without them, the simpler reading is where the weight of evidence sits. The impact claim has not been established. It has been proposed, and it remains a minority interpretation that the specialists do not accept. It is worth describing what that circular tablet actually looks like, because the honest description is fascinating on its own and needs no embellishment. It is a round clay disc, broken and incomplete, recovered from the ruins of the library at Nineveh, and its surface is divided like a pie into 8 equal segments. Each segment is filled with star and constellation names, with simple drawings, and with numerical marks, the signature of an astronomical text rather than a story. It belongs to a known and well-studied family of Mesopotamian sky documents that scholars sometimes call the astrolabes, which list the stars across the 3 paths of Ea, Anu, and Enlil through the 12 months of the year, a kind of star almanac in the round. Seen for what it plainly is, a fragment of a systematic star almanac, it is a genuine treasure, a clear window into how the Babylonians filed the sky by month and by region of the heavens. The disagreement is only over whether it also secretly records one specific dated catastrophe, and the people who read this script for a living judge that the simpler reading, that it is exactly what it appears to be, accounts for everything on the disk without any added machinery. The artifact is real, it is remarkable, and it can be seen. It is only the dramatic interpretation laid over it that has never earned the assent of the specialists. The third reason is the one most specific to tonight's title, and it is the cleanest of all. There is no surviving Polynesian text or chant that names a Mesopotamian deity, references a Sumerian star list, or records contact with the ancient Near East. None. The Polynesian astronomical tradition, as recorded by the navigators themselves and by the researchers who documented it before it could vanish, is internally complete and internally Pacific. Its star names are Polynesian words. Its sky is organized around the navigation problem and the islands of the Pacific. When the legend says the two systems match exactly, what it is actually pointing at is that both traditions use the same bright stars, Arcturus, Sirius, the Pleiades, Orion, the Southern Cross, and the same handful of obvious patterns. But those are simply the brightest, most useful objects in the sky. Every sky-watching culture on Earth uses them, because they are the most visible. Two navigators on opposite sides of the planet, both steering by Sirius, is not evidence of a shared ancient map. It is evidence that Sirius is the brightest star in the night sky, and that human eyes work the same way everywhere. The match is the sky. That is the whole of it, and it is enough. So having cleared the legend, let me spend our longest stretch on the thing that is actually true, because the documented reality of these two traditions is richer than any invented one, and almost every piece of it can be checked by anyone who wants to. Let us go deep, first into the Pacific, then back to the clay. Begin with a single human being, because he is the proof that this knowledge was real and not romanticized in hindsight. In 1769, when the British explorer James Cook was in Tahiti, a Rayatian man named Tupaia came aboard Cook's ship, the Endeavour. Tupaia was a priest and a navigator of the highest training. Over the following months, as the ship sailed thousands of kilometres across the Pacific, into seas Tupaia had never personally visited, the Europeans observed something they could not explain. At any moment, on any heading, asked which way lay Tahiti, Tupaia could point to it, not approximately. He held the direction to his home island in his head continuously, updating it as the ship moved, by a method the Europeans had no name for and could not replicate, a dead reckoning of bearing and distance carried entirely in the mind. He also produced, working with Cook's people, a chart. Tupaia's chart named dozens of islands, by one count well over 70, spread across an expanse of ocean thousands of kilometres wide, an area larger than the continental United States. The chart is hard for modern scholars to read fully, because it uses a Polynesian way of representing space and direction that does not map neatly onto a European grid, but its very existence, drawn by one Pacific navigator from memory in 1769, establishes beyond argument that this was a real and vast body of geographic and astronomical knowledge held without writing 2.5 centuries ago. Tupaia's chart has puzzled scholars ever since, precisely because it does not behave like a European map. For a long time, researchers tried to force it onto a north-up grid and found it full of apparent errors. More recent scholarship, published in the late 2010s, has argued that the chart was never meant to be read that way at all, that it instead encodes sailing directions and the relationships between islands in a Polynesian frame of reference, each island placed according to the bearing you would steer to reach it from a given starting point. Read in its own logic rather than a borrowed one, the chart becomes far more coherent and far more impressive, a different but fully valid way of holding an entire ocean in the mind. The lesson there is worth carrying through the rest of this story. When a record from another tradition looks wrong, the first question is not whether they got it wrong. The first question is whether we are reading it in the wrong language. The knowledge nearly died. Through the 19th and 20th centuries, under colonization and missionization, and the arrival of the magnetic compass and then the engine, the chain of master-to-apprentice teaching that carried Polynesian navigation broke in most of the islands. By the middle of the 20th century, many scholars doubted the islands had even been settled deliberately. The most forceful skeptic was the New Zealand writer Andrew Sharp, who argued in the 1950s that long-distance navigation without instruments was simply impossible, and that the Pacific must therefore have been peopled by accident, by canoes blown off course and carried by chance to new islands. The argument had a cold internal logic. If you begin by assuming no reliable method exists, then deliberate settlement does look impossible, and accidental drift is all that is left to explain the scattered islands full of people. Sharp's challenge stung, and it set the terms of the debate for a generation. The trouble was that you cannot refute a claim about what is possible with another argument about what is possible. You can only refute it by doing the thing. The answer to Andrew Sharp could not be written. It had to be sailed. That doubt is what makes the next chapter so important. In 1973, the anthropologist Ben Finney, together with the artist and waterman Herb Kawainui Kane and the canoe paddler Tommy Holmes, founded the Polynesian Voyaging Society, with the goal of building a traditional voyaging canoe and sailing it the old way to settle the question by experiment. That canoe was Hokulea, but to sail it without instruments, they needed a navigator who still held the living tradition, and in Hawaii there was no longer anyone who did. They found their navigator far to the west, in the Caroline Islands of Micronesia, where the art had survived. His name was Mul Apin, a master navigator from the tiny island of Satawal, one of the last men alive who had been trained in the traditional way from childhood. In 1976, Mul Apin navigated Hokulea from Hawaii to Tahiti, more than 4,000 kilometers across open ocean, with no instruments, finding the islands by the stars, the swells, the wind, and the birds. The drift theory died on that voyage. The voyage proved the navigation was real. Then Mul Apin did something that changed the trajectory of the whole revival. He taught. His most important Hawaiian student was Nainoa Thompson, the man who would go on to systematize the Hawaiian star compass we discussed earlier. Thompson studied the sky obsessively. He spent long nights inside the planetarium of the Bishop Museum in Honolulu, working with the astronomer Will Kaselka, who could run the dome's projected sky forward and backward and freeze it at will, so that Thompson could learn the rising and setting points of star after star and watch how the whole turning sphere moved through a night and through a year. From that study, and from what Mul Apin had taught him by eye and by hand, he rebuilt a complete naked-eye navigational system suited to Hawaiian waters, the star compass we walked through earlier. It was an act of reconstruction as much as inheritance, a nearly lost science pieced back together from a living teacher, a planetarium dome, and the real sky over the Pacific. In 1980, Thompson navigated Hokulea to Tahiti and back himself, the first Hawaiian to do so by traditional means in roughly 600 years. And the tradition, once revived, kept growing. Decades later, between 2014 and 2017, Hokulea completed a voyage around the entire world, a circumnavigation of roughly 70,000 kilometers, crewed by rotating teams of navigators trained in the revived art, returning home to Hawaii in June of 2017. The knowledge that nearly vanished now sails farther than it ever did in antiquity, and every kilometre of it is steered by the same principle the Mesopotamians filed under 3 roads on a clay tablet, the principle that a star's rising point on the horizon is a fixed and usable direction. It is worth pausing on the sheer scale of what these methods accomplished, because the magnitude, once you spell it out, is staggering. The Austronesian-speaking peoples, of whom the Polynesians are the easternmost branch, carried out the largest maritime expansion in human history before the age of European sail. Setting out ultimately from the region of Taiwan and island Southeast Asia, they spread across an arc of the planet that runs from the great island of Madagascar, off the coast of Africa, eastward all the way to Rapa Nui, the remote island we also call Easter Island, far out towards South America, and north to Hawaii and south to New Zealand. That arc spans more than half the circumference of the Earth. They crossed it in open canoes, finding specks of land in an ocean that covers nearly a third of the globe, and most of those specks are so small and so far apart that missing one by a few kilometres means seeing nothing at all and sailing on into emptiness. And they did not merely arrive, they arrived prepared to stay. The voyaging canoe was a double-hulled vessel, 2 long hulls lashed to a central platform beneath crab-claw sails, and it carried not just people, but a whole transported world, the shoots of taro and breadfruit, pigs and chickens and dogs, the living cargo of colonists who meant to build a home at the far end of the crossing. This was not drifting. This was settlement by design, planned and provisioned and aimed across the widest water on Earth. The modern revival did something its founders may not have fully foreseen. It did not stay in Hawaii. The knowledge Maupiailug carried, from Satawal and that Nainoa Thompson rebuilt in the islands, was taught onward to navigators across the Pacific, and traditional voyaging canoes and trained wayfinders now sail again from places where the art had been silent for generations. Maupiailug, before he died in 2010, took the extraordinary step of formally passing on his knowledge in a graduation ceremony, deliberately breaking with the old secrecy, because he judged that the only way to keep the tradition alive was to give it away widely rather than guard it narrowly. A body of knowledge that had nearly vanished within living memory is now more widely held than it had been in a century. The clay tablets of Mesopotamia preserved that civilization's sky knowledge by accident, baked hard in destruction and buried until archaeologists dug them out. The Polynesian sky knowledge was preserved on purpose, by human decision, by teachers who chose at the last possible moment to hand it forward. Two ways of surviving across time: the durable accident of fired clay and the deliberate act of teaching, and both, against long odds, worked. The texture of the Polynesian method is worth lingering on, because it is the texture that the legend always flattens. Stars are the framework, but a master navigator reads the whole world as instrument. The ocean's swells are a primary tool. In the open Pacific, long-travelling swells generated by distant, steady weather systems roll in stable directions for thousands of kilometres, and a trained navigator feels the dominant swells through the hull and through his own body, even at night, even when clouds hide every star, and holds a heading by the angle of the canoe to the swell. Where swells from different directions cross, they make a characteristic interference pattern, a kind of choppy signature, and the navigators of some islands learn to read these patterns to detect the presence and direction of land far over the horizon, because islands bend and reflect swells in detectable ways. Birds are another tool, precise and beautiful. Certain seabirds, the white tern and the noddy among them, sleep on land and fish at sea, flying out from their island at dawn and back to it at dusk. A navigator who sees such a bird in the evening, its beak empty, heading purposefully in one direction, has been handed an arrow pointing at land because that bird is going home to roost. Clouds, too, are red. A stationary cloud in a sky of moving clouds may be anchored over an unseen island, and the underside of a cloud can take on a faint greenish tint over a shallow lagoon, or a pale glow over white sand or surf. The stars give the framework. The swells, the birds, and the clouds fill it in. Much of this was documented in the 1970s by the physician and sailor David Lewis, who learned from surviving Pacific navigators and recorded their methods in his book, We, the Navigators, published in 1972, a work that helped rescue the knowledge at the edge of its disappearance. The navigators also carried a mental bookkeeping system for tracking how far they had come, and the version best documented in the Caroline Islands, where Maupiailug learned his art, is called ETAC. It inverts what a modern chart would do. Rather than picturing the canoe moving across a fixed sea toward a fixed island, the navigator holds the canoe still in his mind, at the centre of everything, and imagines a reference island off to the side sliding backward past a sequence of star bearings as the voyage runs on. Each time the reference island lines up with the next star along the horizon, another stage of the journey is complete. It sounds abstract, and it is, but it is a remarkably efficient way to keep continuous track of position entirely in the head, with no instrument and nothing written down, the same running dead reckoning that so astonished Cook's crew when Tupaya held the bearing to Tahiti hour after hour and day after day. David Lewis recorded attack and much else from the surviving navigators in the 1960s and 70s, setting it down in time just before the last fully untaught generation would have carried it into the grave. There is a strategic depth to all of this that is easy to miss, and it shows the navigators thinking like risk managers, not romantics. The hardest problem in open ocean navigation is east and west position, what we now call longitude, because while a zenith star or the height of the southern cross can pin your north-south latitude, nothing in the naked eye sky directly fixes how far east or west you have travelled. The Pacific navigators answered this with technique rather than instruments. They would deliberately aim to one side of a target island rather than straight at it, so that when they reached its latitude they knew with certainty which way to turn and run, instead of guessing left or right and possibly missing the island into open ocean forever. They learned to read the screen of signs that a piece of land throws out far beyond its visible shore. the reflected and bent swells, the daily flights of nesting birds, the anchored cloud, the loom of green light off a lagoon, so that a single small island became a much larger target, a zone of clues many kilometres wide rather than a dot. And the boldest strategy of all was the choice of direction. Much of the settlement of the eastern Pacific ran against the prevailing trade winds, eastward into the wind, and this was almost certainly deliberate. Sailing out upwind meant that if you found nothing, you could turn and run home swiftly on the same wind that had fought you on the way out. It is a strategy that treats exploration as survivable, a way to go looking for new land without betting your life on finding it. Periodic reversals of the trade winds, linked to the climate pattern we now call El Nino, may have opened windows when the eastward voyages were easier, and the navigators, reading the wind across years, would have known when those windows came. Now turn back to the clay, and let us be just as concrete about what the Mesopotamians actually did, because their achievement is just as real and far older. The text Mul Apin, the Plough Star, is our richest single window into their organised star knowledge. Its first tablet opens with a catalogue of roughly 60-some stars and constellations, sorted into the three paths of Enlil, Anu, and Ea, the northern, central and southern bands of the rising sky. It then gives the dates of heliacal risings through the year, the calendar of first dawn appearances we discussed. It lists which stars rise as others set. The same handing-off relationship the Polynesians used at sea, here used to tell time at night. It describes the path of the moon and the planets through a band of constellations along the ecliptic. And it gives rules for the calendar, including the insertion of extra months to keep the lunar year aligned with the solar seasons. This is a working astronomical handbook. The oldest copies we have were written around the 7th century BCE, with one well-known copy dated to the early 7th century, but internal evidence, the positions the risings imply, points to the underlying observations being older, reaching back toward the 2nd millennium BCE. Older still is a specific and astonishing record, a tablet that preserves observations of the planet Venus made during the reign of a Babylonian king named Amisaduqa in roughly the 17th century BCE. The Venus observations record the dates when Venus first appeared and disappeared as a morning and evening star across a span of years, and because the motions of Venus are so regular, modern astronomers have been able to use these ancient sightings to help anchor the chronology of the entire period. Think about what that means. An observation written in clay 36 centuries ago is precise enough that we can still use it to fix dates today. That is not myth. That is data, surviving across the deepest reach of recorded time, still doing scientific work. And it was made by people watching the same Venus that hangs over your own evening horizon tonight. The reason the Mesopotamians watched so relentlessly was, at the beginning, not science as we would define it, but divination. The Great Omen series called Enuma Anu Enlil spread across roughly 70 tablets, collected celestial signs together with their meanings, on the principle that the gods wrote their intentions in the sky, and a trained scribe could read them. When the moon was eclipsed, when a planet stood in a particular place, when a ring of light haloed the moon, the omen text told the king what it foretold: famine or flood or the fate of the throne. In its purpose this was superstition, but the side effect was profound, and it is the heart of the matter. To read omens reliably, you must first be able to anticipate where the lights in the sky will be, and to anticipate where they will be, you must record where they have already been, accurately, across a very long span of time. The hunger for meaning in the sky drove the creation of real, observational discipline. The omens were the motive, the data was the result, and the data outlived the motive by thousands of years. To tell time through the night, the Babylonian astronomers used a method that will sound familiar after the Polynesian star paths. They identified a set of stars, which scholars call the Zeekbu stars, that pass directly across the highest line of the sky, the meridian overhead, one after another through the dark hours. By watching which of these culminating stars stood at the top of the sky, an observer could read the hour of the night and time the rising of the moon or a planet against it. A Polynesian navigator handed his heading from star to star along the horizon to hold a direction. A Babylonian astronomer handed the hour from star to star across the top of the sky to hold the time. The same handing-off relationship between rising and setting and culminating stars, turned by one culture into a compass, and by the other into a clock. By the later centuries of Babylonian astronomy, in the age after the Persian conquest and into the time of the Greeks, the scribes had turned all that accumulated data into genuine mathematical prediction. They built what scholars now call the ephemerides, tables that computed the future positions of the moon and the planets using arithmetic alone. They worked with two main kinds of pattern. In one, a quantity holds at a fixed value for a stretch and then jumps to another, a step pattern. In the other, it climbs and falls in even increments between a high point and a low point, a pattern that traces a zigzag when you plot it across time. With these techniques, and with long cycles distilled from the diaries, including the roughly 18-year eclipse cycle and the repeating periods of each planet, they could compute eclipses and the appearances of planets years into the future, on clay, with no telescope, no physical model of the solar system, and no concept of orbits, purely from the extracted regularities of centuries of patient watching. It stands among the first fully mathematical sciences in all of human history, and it grew, tablet by tablet, from a scribe pressing the night's observations into clay, night after night, for the better part of 600 years. There is one more piece, and it is the kind of forensic detail that lets a modern researcher check the work of an ancient one. The Earth's axis does not point in a perfectly fixed direction. It wobbles slowly, like a spinning top winding down, completing one full circle of wobble over roughly 26,000 years, a motion called precession, first clearly described by the Greek astronomer Hipparchus in the 2nd century BCE. Because of precession, the rising points of the stars on the horizon and the dates when each star first reappears at dawn drift very slowly across the centuries. This means the rising dates written into a star catalogue carry a hidden timestamp. When scholars take the heliacal, rising dates recorded in Mul Apin and ask what epoch they fit best, the answer comes out earlier than the surviving copies of the text, pointing back toward the 2nd millennium BCE for the original observations behind it. The clay copy in the British Museum was written in the 7th century BCE, but the sky it describes is older than the tablet, and we know that because the real sky kept moving afterward and left the record measurably out of date. The observation and the object that records it can be dated separately by the very physics the observers were unknowingly recording. That is about as close to a fingerprint as the ancient sky ever gives us. Behind all of this stood an institution, and that is the last thing to understand about the Mesopotamian achievement. This was not a handful of inspired individuals working alone. It was a profession, a class of trained scholars attached to the temples and the royal court, who watched the sky as a duty of state and reported what they saw to the king. From the 7th century BCE, we have the actual letters and reports these scholars sent to the Assyrian kings, surviving by the hundreds, telling the throne what the heavens had shown and what it meant, sometimes hedging, sometimes arguing openly with one another, sometimes admitting that clouds had hidden the crucial sign on the crucial night. They developed specialized kinds of text for the work, including what scholars now call the goal year texts, which gathered together, for a particular target year, the relevant observations from the right number of cycles earlier, so that the recorded past could be used to forecast the coming year. It was a deliberate, institutional, multi-generational program of observation, prediction, and record-keeping, sustained across centuries by people doing it as their occupation. The Polynesian system was institutional too, in its own fashion, carried not by temple scribes, but by the guild-like training of navigators, master to apprentice, with the same multi-generational discipline holding it together across the gaps between lifetimes. Two completely different societies, two completely different ways of organizing knowledge, and both arrived at the same conviction, that the sky is worth the sustained, lifelong, institutional attention of a society's most carefully trained people. The Mesopotamians also gave us a piece of the sky we still carry without realizing it. The constellations of the zodiac, the band of star patterns the sun appears to pass through over the year, were systematized in Babylon, and by around the 5th century BCE the Babylonian astronomers had taken a crucial further step, dividing that band into 12 equal segments of 30 degrees each, the 12 signs. That division, 12 equal signs of the zodiac, is a Babylonian invention, and many of the individual constellations are Babylonian too, passed down to us through the Greeks. The Babylonian bull of heaven became the Greek and modern Taurus, the lion became Leo, the great twins became Gemini, the scorpion became Scorpius. When you read your star sign in a newspaper, you are reading a fragment of Mul Apin, transmitted through more than 2,500 years of unbroken cultural inheritance. And that last phrase, unbroken cultural inheritance is the hinge of our next point, because it lets us see clearly what real transmission looks like, as opposed to the independent convergence we have been describing in the Pacific. This is the comparison that sharpens everything, so let me set it out deliberately. We have, in the historical record, a clear example of genuine astronomical transmission, knowledge actually passed from one culture to another by contact. It is the line that runs from Babylon to Greece. After the conquest that brought the Greek world into close contact with Mesopotamia in the centuries before the Common Era, Greek astronomers absorbed Babylonian methods directly. They took the sexagesimal system, the counting in 60s, which is why we still divide an hour into 60 minutes, and a circle into 360 degrees. They took the zodiac and its 12 signs. They took specific constellations and specific records, and Greek astronomers like Hipparchus, in the 2nd century BCE, are documented using Babylonian eclipse observations directly in their own work. That is what transmission leaves behind. It leaves shared technical vocabulary, shared arbitrary conventions, shared specific data, and a traceable path of contact, written down, that the two cultures sat in the same rooms and one learned from the other. Now compare that to the Pacific. Between Mesopotamia and Polynesia, there is no shared vocabulary, no shared arbitrary convention, no shared specific record, and above all no path of contact, because the Pacific Islands were settled by people coming from the opposite direction, from Asia and across the open ocean, more than 1,000 years after Mul Apin was compiled, and they never crossed the landmass of Eurasia to meet the heirs of Babylon. What the two share is not the arbitrary conventions that mark transmission. They do not share a sexagesimal system. They do not share the 12-sign zodiac. They do not share specific star names or specific recorded dates. What they share is only the deep structure that the sky itself forces on anyone who reads it carefully, the horizon as a dial, the rising point as a coordinate, the bright stars as anchors, the long cycles as the prize. The Greeks and Babylonians share the fingerprints of contact. The Polynesians and Babylonians share only the fingerprints of the sky. Once you can see the difference between those two kinds of sharing, the legend dissolves and something more remarkable stands in its place. We are looking at a controlled experiment that history ran for us. Give two utterly separate civilizations the same sky and the same hard need to read it, and watch what they build. They build the same deep structure and different surfaces. That is one of the cleaner demonstrations we have that some kinds of knowledge are discovered, not invented, lying latent in the world for any sufficiently careful observer to find. And the Pacific and Mesopotamia are not the only 2 points on this curve. Look at ancient Egypt, a third civilization, again with no relevant contact with the Pacific, and you find the same deep structure put to yet another local purpose. The Egyptians divided the sky into 36 groups of stars they used to mark the passing hours of the night, groups that modern scholars call the decans, because across the year they governed the calendar in stretches of about 10 days each. These decans were painted on the inner lids of coffins as early as around 2000 BCE, so that the dead could keep track of the hours in the afterlife, a star clock for eternity. And the single most important star in the entire Egyptian sky was one we have already met as a Polynesian zenith star, Sirius. The Egyptians watched for the dawn return of Sirius after its long season of invisibility in the sun's glare, because its first reappearance fell at almost exactly the moment the Nile began its life-giving annual flood, and that rising opened their year. So here is one bright star, Sirius, doing 3 entirely different jobs in 3 unconnected cultures. In Tahiti it is a zenith star, a marker of latitude for finding an island in the open sea. In Egypt it is the calendar star, its dawn rising announcing the flood and the new year. In Mesopotamia it sits in the Great Star Catalogue among the constellations of the southern path of Ea. One star, the brightest in all the night sky, seized upon by every culture that watched the heavens with care and bent to whatever each one most needed. That is not transmission from a common source. That is what happens when a single, brilliant, fixed point hangs over every human head on Earth at once, and patient people everywhere notice it and put it to work. I want to give the opposing case its strongest form before we close, because steel-manning the objection is the only honest way to hold a conclusion. The strongest version of the transmission argument is not the Anunnaki version. It is a sober diffusionist version, and it goes like this. Human beings have been moving and trading and talking for a very long time, far longer and farther than we often credit. Ideas travel, We know the zodiac travelled from Babylon to Greece to India and onward. We know mathematical and astronomical concepts crossed enormous distances along trade routes. Is it not at least possible, a careful diffusionist would ask, that some kernel of sky knowledge spread across human populations deep in prehistory, before writing, carried by the same migrations that peopled the world, so that what looks like independent invention is actually the faded echo of a very old common inheritance, too old to leave a paper trail? That is a serious argument, and I do not want to wave it away. It is true that ideas travel, and true that the absence of a record is not by itself proof of the absence of contact. But here is why the argument does not carry in this specific case, and the reason is the same divergence on purpose pattern we keep returning to. If the two systems descended from a shared deep inheritance, we would expect them to share some of the arbitrary stuff, the conventions that are not forced by the sky and could have gone many ways. We would expect a shared way of counting, or a shared set of constellation pictures beyond the few obvious ones, or a shared calendar structure, or a shared name surviving for at least one important star. We find none of that. Every arbitrary feature of the two systems is different. The Polynesians did not count in 60s. They did not divide the ecliptic into 12 equal signs. Their constellation pictures, where they drew them, are their own, tied to Pacific objects and stories. The only things the two systems share are the things no culture could fail to share if it looked up with care: the bright stars and the horizon, and the cycles. A shared inheritance would have left shared arbitrariness. We find shared necessity and divergent arbitrariness, which is the exact signature of two minds solving one problem with the same materials and no contact. The diffusionist hypothesis is not impossible. It is simply unsupported by the one kind of evidence that would distinguish it from independent invention, and contradicted by the pattern of what is shared and what is not. I want to grant the careful diffusionist one real point, because it is true and it is interesting. There may well be genuinely ancient, broadly shared human sky law, older than any of these civilizations. The fascination with the Pleiades, again, turns up so widely across the world, including among peoples whose ancestors separated from one another tens of thousands of years ago, that some researchers have seriously wondered whether a kernel of Pleiades story is genuinely that old, carried out of a common human past before the Great Migrations. That is a real and open question, and it deserves respect. But notice that it is not the same claim as the legend. If it is true, it would mean only that human beings have been noticing the same obvious little cluster, and telling stories about it for a very long time, which is the discovered not invented thesis extended deeper into the past, not a rival to it. It would not mean that a single advanced civilization handed down a finished star map to its chosen heirs, and it would say nothing whatever about the Anunnaki. Even the deepest honest version of the shared knowledge idea still points back to the same place. It points to the sky as a common inheritance for the whole species, not to a secret delivered to a favoured few. What follows from all this, in the end, is a change in how we should see both of these peoples. The Polynesians were not lucky drifters, and the Mesopotamians were not primitive stargazers reaching for omens in the dark. Both were the bearers of real, hard, observational sciences, built from nothing but the naked eye, patience across generations, and the disciplined refusal to mistake a guess for a measurement. They were doing the same essential thing that astronomers do today, extracting the regularities of the sky and putting them to use, and they arrived at the same deep structures because those structures are really there, in the sky, waiting. The legend tried to make them impressive by linking them to a secret ancient source. They do not need it. They were already doing the thing that is actually hard, which is to look carefully at the world and get it right, with no instruments and no help, on opposite sides of the largest ocean on Earth, never knowing the other existed. And there is a quieter consequence, one that reaches past these two peoples to the rest of us. We tend to imagine that real knowledge of the heavens began with the telescope, that everything before it was myth and guesswork dressed up in ritual. These two records say otherwise. With nothing but the unaided eye, disciplined attention, and the patience to watch, across a full human lifetime, and then hand the watching on, both of these cultures pulled true and usable structure out of the sky. The Babylonians predicted eclipses they had no physical theory to explain. The Polynesians crossed an ocean that later sailors, equipped with charts and compasses, still feared to enter. The instruments came afterward, and they mattered enormously, but they were not the beginning of knowing. The beginning of knowing was a person standing still under the stars, paying close attention and refusing to forget. That capacity did not require Sumer to teach Polynesia, or any vanished civilization to teach either one of them. It required only the sky, which was free to all, and the discipline to read it, which was not free to anyone. Both peoples paid that price in full, and the proof of the payment is that their knowledge worked. There is a double-hulled canoe tied to a pier in Honolulu, named for a star that sits at the top of the Hawaiian sky. And there is a clay tablet in a museum in London, pressed with a list of stars sorted by where they climb over the horizon, written by people who never imagined an ocean so wide or a canoe so bold. The two were never in contact. They never traded a word or a chart or a single star name, and yet, read carefully, they rhyme, because the sky they were both reading is the same sky, and it is still up there tonight, turning over your own head, anchored to the same horizon, keeping the same cycles, waiting for the same careful attention it has always rewarded. The match was never a mystery to be solved. It was an invitation, offered to everyone to look up and see what is genuinely there. The question worth keeping is not who told them the secret. It is how much of the sky is still sitting in plain sight, waiting for the next careful eye to read it.